Hello and welcome back to PC Retro Programmer. Today's video is the first in a series of videos wherein I'm going to attempt to get a linearly addressed graphics mode on the Tandy 1000SX. Now, due to the nature of the task, this is going to require some background knowledge, but fortunately I've already covered all the relevant material on the channel in the Advanced CGA series. You're going to need the videos on linearly addressed modes. I think there's a couple of those, and also on the CRT controller registers, which is another video in the Advanced series. So if you've been able to follow those, you should be able to follow this set of videos. Now, the reason that the CGA CRT controller registers are relevant here is because they exist on TGA. TGA is basically an extension of CGA, and the megacell architecture there basically emulates the MC6845 chip, the CRT controller, on the CGA card. It's also used on other video cards as well, of course. And so that means that anything that works there should work here. Now, unfortunately, you might recall we weren't able to get a full screen linearly addressed mode in the case of CGA due to some technical obstacles. We were only able to get a half screen mode, and I will leverage that later on the channel and we'll see what advantages it has. But it would be really nice to be able to get a full screen linearly addressed mode, especially if it could be done cheaply. Now, I had a talk to Ralf about this, who's a demo scener that I'm in contact with, and certainly the source of a lot of the technical information that I have on the CGA. And it's his opinion that it might actually be possible there. But unfortunately, it involves a very advanced technique which neither of us have actually tried yet, and which actually requires a lot of CPU babysitting, so it wouldn't actually be faster. And performance is one of the main reasons that you would want a linearly addressed mode. In the case of VGA, for example, all the pixels are just one after the other in video memory, and so this makes addressing them very straightforward and very fast. But it's not the same in the case of CGA and TGA. In the case of CGA, there are two banks. All of the even scan lines are in the first bank, and all of the odd scan lines are in the second bank. And for TGA, it's even worse. There are four banks. So whenever you want to change scan lines, you have to switch banks, and so you need code and, of course, CPU cycles for that. And this makes drawing lines and circles and other primitives that cross a lot of scan lines quite expensive on CGA and TGA. So, although it's not really possible without a lot of CPU babysitting in the case of CGA, I'm more hopeful in the case of the Tandy 1000SX. There's two reasons for that. First of all, it's a much more advanced architecture. There's just simply more things we can try. And secondly, I found a document in Trixter's archive. Trixter's another demo scener that I'm in contact with, and he has an FTP server where he's been collecting information for years. And there's a particular article there that mentions a linearly addressed mode on the Tandy 1000. And according to that article, it works just fine on the 1000EX and later. Now, of course, that excludes the SX, unfortunately, but I'm hopeful that if we try it, it'll either work and it'll just happen to be the same on the SX, or we'll learn why it doesn't work, and with a few additional tricks, we might be able to coax it into doing what we want. And I have basically two ideas that go beyond what's in that article that, with any luck, are going to get us to a full screen mode. Along the way, even if it doesn't work, we're certainly going to learn a lot, and in particular, I think that there is a very high probability that we'll at least be able to get a two-bank mode on the Tandy 1000SX. I can't promise anything, but there is definitely hope that we can get a full screen mode on the 1000SX as well. So let's take a look at what's different about the Tandy 1000SX. It has numerous additional registers that are not present on CGA, of course. Now, a lot of the information that I'm giving today is from the Tandy 1000SX reference manual, which I've linked in the description below, But there's also some guesswork on my part because the manual isn't super clear at certain points. I've asked Trixter for an opinion on this because he's much more familiar with the Tandy 1000 line of computers than I am in general. Now, it seems to me that there are two ports of interest. There's 3DD in hexadecimal, the extended RAM page register, and 3DF in hexadecimal, the CRT processor page register. And these are not available on CGA because these relate to the special way that the Tandy 1000 and actually the IBM PC Junior, as it happens, address memory. So instead of having dedicated chips on a video card as we do with CGA, the TGA and PC Junior have a controller that shares memory between ordinary system RAM and the video controller. Now, the way it works in TGA is that you actually get to select a 128 kilobyte block of ordinary system memory that is shared with the video controller. And this is done using the NMI mask register at port 0A0 in hexadecimal. And there you can specify which 128K block you want in 128K start address increments from the beginning of memory. As it happens, when you reset the machine, this register gets zeroed out, so you end up with a start address of 0000, and we know that segment 0000 is overlapping the interrupt vector table. So what this means is you actually can't use all of that 128K block for the video memory. Otherwise you'd overwrite the vector table and the machine would stop working. But there's still plenty of space left to have numerous pages of video RAM. This is really great because pages are very useful in graphics programming. You can do page flipping, you can composite your image on one page whilst another page is being displayed on the screen and avoid any interference between the two. And you can also do animation and a whole bunch of other tricks with paging. So this is possible on CGA, and I'll explain how the two are separated in a moment. First of all, I want to mention that there are actually two different kinds of Tandy 1000s. There's 128K systems and 256K systems. And obviously in the 256K system, there's 256K of shared memory. This is an option you have to enable. There's a bit for that, of course. And this really isn't so important for us. We don't need the extra memory. There's plenty of pages already in 128K to do what we want. But we do need a 256K system, and that is because one of the bits that we need to set, this bit 0 here, is only available on 256K systems according to the SX manual. Now, I haven't managed to verify that myself. I only own an SX, but it's good for us that this should work in our case. Now, the way the 128K or 256K is laid out depends on values in these two registers, in particular in bit 0 of port 3DD, the extended addressing mode bit, and that's the one that's only available on 256K systems. Otherwise, it's just assumed to be 0 on the 128K systems. And there are also bits 7 and 6 of port 3DF, the so-called video addressing mode bits 6 and 7 in this port. And together those three specify the layout of this 128K block of shared memory. So if they're all set to 0, then you get 8 pages, each of 16 kilobytes, and that adds up to 128K total, as all of these options will. And in the case of 256K systems, there's just twice as many pages. But this isn't really relevant for us, as I said. If you select 001, you'll still get 8 pages of 16K, but this time there's 2 banks of 8 kilobytes in each page. And this is important because if you want to emulate CGA, you need 2 banks of 8K, since that's how it's laid out. Of course, normal CGA just has a single page, whereas here we can actually choose 8 different pages if we're prepared to fiddle around with the page register. And the option we're interested in today is this one here, because this will give us 4 pages of 32 kilobytes. And notice we need to set this bit in that case, and that's why we need a 256K system according to the manual. And the reason this is interesting is because the 320 by 200 16 color mode uses 32K, but normally it uses 4 banks of 8 kilobytes, and that's where we get our 4 banks from. So if we want to do linear addressing, it seems all we need to do is change this 011 to 100, then we'll just have a single bank all linearly addressed. Well, why don't we just try it out? Well, that's actually what we're going to do in today's video. But according to the notes in the archive of Trixter that I found, it turns out this trick only works on EX and later machines. Now, I don't really see anything from this information here that should prevent it working on the SX, and who knows, maybe we'll get lucky, maybe it just works. But there are some possible reasons why it may not. We'll try it and find out, and if it doesn't, then I have a couple of ideas, as I said, that we'll look at in later videos to try and work around those limitations. But before we jump right into it, there's a couple of other things that we need to look at. What are the CRT page bits about, and the processor page bits, for example? There's 3 bits in each case, and that allows us to store values 0 through 7 in each case. And of course, these are the pages that we're selecting out of the 8 possible pages, or in our case it'll just be 4 pages. And they're separated because as I said, you can be displaying one page on the screen, the one that you select here, and at the same time be modifying a different page, the one that you select here. Or in the case of traditional CGA, I guess these would have to be the same. So that's what these are about. So in the case of 4 pages, it turns out we only use the top 2 bits of these 3-bit values. And in the 2-page mode, we just use the top bit. And we can think of the other bits as just being 0. It turns out they can have another interpretation, but I'm not going to go into that here because it's not actually important for what we're going to do. So what about these other bits here? Well, on a 256K system, you get twice as many pages, and so you could have as many as 16 pages, for which you're going to need 4 bits, not 3 in each case. And so it turns out that that extra bit is here, or at least I assume so. It's not clear from the manual because it says video page here and CRT page here, and it says CPU page here and processor page here. But I think this is just a quirk of the manual. This is just a 4th bit in each case. But what is this address 17 all about? This doesn't seem to correspond to anything we've seen here. Well, I think we can figure that out too. If you had 8 pages, for example, each of 16 kilobytes, then the pages are on 16K boundaries, which is 4000 in hexadecimal, which is a 1 with 14 zeros in binary. So in other words, address lines 0 through 13 are all going to automatically be 0 for every one of these pages. So we don't have to represent those in these registers. They're all zeros anyway. And so it's only address lines 14, 15 and 16 that we need to fiddle with if we have 8 pages. And that's precisely these 3 bits here. And if we have 16 pages, we'd need 1 more address line, which would be address line 17. So I think that's what's going on here, at least that makes the most sense. And it certainly squares with the fact that we only use the top 2 bits in the case of 4 pages, and the top bit in the case of 2 pages. After all, if we had a 64K page, this would have an additional 2 zeros in the address, and so that would make sense that we're only modifying the top bit here, the other 2 bits being 0. So I think we have figured out now exactly what these ports do. It's time to hop to it and try this out. Now we'll probably need to fiddle with the CRT controller registers as well and set the number of rows of characters on the screen and the number of scan lines per character. But those are things that we can do because the CGA CRTC registers are available just in the same way that they are on CGA. So let's program all of this up and see if it works. Now I've called this file tndylinr.asm, and this just stands for Tandy Linear, of course. Now this is a duplicate of tandypoint.asm, which we developed on the channel previously for drawing a dot on the screen in Tandy Mode 9, the 320x216 color mode. So the main program here just draws some diagonal lines on the screen by calling this Tandy point drawing function over and over again. So let me skip down to where I've actually made changes to this. So here's the main program. And of course the first thing it did was to change into Tandy Mode 9, the 16 color mode, and here's the new code. There's actually not very much of it. Now the first thing we need to do is to figure out what the current CRT and CPU pages are. And the reason for that is we need to fill these values in when we change the register at port 3DFH. The only problem is we don't have any idea what they currently are. I don't know what the default values are on Tandy, and I wasn't able to find this out. And the problem with finding out what the values currently are is that those registers are write only. So we can't just read them to see what values they currently contain. But it turns out that there is a way to find out what they're currently set to. It took me a while to find this, and it turns out it was actually a forum post by Trixter that tipped me off in the end. And if you look in Ralf Brown's interrupt list, you'll find that there's actually a BIOS video interrupt on the Tandy 1000 for getting the current CRT and CPU pages. So it's function 0580 of the BIOS video interrupt, interrupt 10H. Now you might wonder, how does the BIOS figure out what the values are if it can't read the registers? Well, the BIOS knows because the BIOS set those values up in the first place. So basically, when the machine is started and the video BIOS gets initialized, it stores the values somewhere that it's setting those registers to. And so when you use this function, it just returns the values that it has saved away. And so that's why we can get those from the BIOS itself. So we just run this function, and now BH will contain the CRT page and BL will contain the CPU page. So now we're all ready to set up the byte that we're going to want to put into the register at port 3DF. So first of all, we just copy the CPU page value into a register, and the port at 3DFH is going to expect this to be in the 3 bits from bit 3 to 5. So what this means is we need to shift that value left by 3 bits so it's in the right location. So that's what the first 3 lines of code do here. And then we need to put the CRT page in, which is bits 0 to 2. And those are actually already in the right bits, just in the BH register. So we just OR that with the byte that we're setting up in AL. And now we have all 6 of those bits set to what they currently should be. Now we're ready to change the bits 6 and 7, the video addressing mode bits. Those are the bits that we want to change to zeros according to our little table on the left there. And of course we don't need to do anything for that because the values will already be 0 in this byte in AL since we didn't put anything in those top 2 bits. And so now we're ready to just write that byte out to the register at port 3DFH using an outdxal. So now we should have the 2 bits in the register at 3DFH set correctly. The only thing that we want to do now is to set the extended addressing mode bit, bit 0 of port 3DDH. Now the other bits here we can just set to 0. We're not using address line 17, and there are actually some bits in that register for address line 18, but according to the Tandy manual this was never implemented anyway, so you can just think of those as reserved bits if you like. And so basically we could just set all other bits in this byte to 0. They're either not used or reserved. And so we only need to change the bit 0 to a 1. So we just put the value 1 in AL. And so we output that to the port at 3DDH, and that takes care of the extended addressing mode bit. So that's really all there is to it. From here, the code is identical to what it was before. It just draws some diagonal lines on the screen by putting values into video RAM. So let's save this code and we'll assemble it and run it and see what actually happens on genuine hardware, of course. So I am using a genuine Tandy 1000 SX for this video. So we'll just link this file and we'll switch over to the real hardware to see what actually happens. Now before we run the code, it's interesting to speculate what might actually happen here. We've set things up so that there's a single page of 32 kilobytes, but this is not what the CRTC is expecting. It's still set up with 50 character rows in the vertical direction, each character being 4 scan lines high. And normally it would take each of those scan lines for the character from a different bank, but of course we've got rid of the banks now. There's just a single bank, so where is it going to get its information from? So one possibility is that it just decides that things are set up incorrectly and gives us a blank screen. I think that's the least likely option, but it's still a possibility. Another option is that it says, well, I'm expecting there to be 4 banks, and then just interprets that single page of 32 kilobytes as 4 banks of 8K. I think that's also unlikely because the hardware shouldn't allow it to do that. So that would be the worst outcome because it would mean that it's completely ignoring our values altogether. Another possibility is that it goes looking for those scan lines in banks that no longer exist, doesn't find those banks, and so just outputs black, so that we only get every 4th scan line showing. Another possibility is that it repeats a scan line 4 times with the same information from that first bank instead of getting scan lines from alternating banks. So I really have no idea what it's going to do here, and the only way to find out is to run the code and see what happens. So let's do that, and yeah, this is looking good. So technically speaking, we actually already have a linearly addressed mode here. This is a 320 by 50 linearly addressed mode. So this could actually be useful in practice. But of course this is not what we're aiming at. We want a 320 by 200 linearly addressed mode. So what needs to change from here is that we need to change the character height from 4 scan lines to 1, as we did in the linearly addressed video for CGA. So we'll apply the same tricks in the next video to actually try that out. And the big question will be, will we get just a quarter of a screen linearly addressed, half a screen, or a full screen? And I have no idea of the answer. That's what we hope to find out. And if it doesn't work the way that we want, as I said, there are some ideas that are possible on the Tandy 1000 which are not possible on CGA that we can try in order to trick it into doing what we want. So that's basically the schedule for the next few videos.